Now that we've gone through the introduction on periodic trends, we're going to start the first of several lectures on specific trends. And we'll start with the atomic radius. Now, just a few things to remember. A period is a row across the periodic table. A group is a column in the periodic table. An explanation is the rationale for a claim. The electron configuration is where the electrons reside. The effective nuclear force, or ZEF, is the apparent positive charge seen by an electron. Coulomb's law states that force is related to Q1 times Q2 divided by D, where Q1 is the effective nuclear charge, Q2 is -1 because that is the charge of an electron, and D is the distance between the points that we're looking at. So now we can define atomic radius, which is the distance from the nucleus to the outermost electrons. And if we graph those distances out in picometers versus the atomic number, you get a graph that looks like this. And the first thing to notice about this graph, it has a very distinct shape. And this shape is called a sawtooth pattern, which is classic for a periodic or a repeating function. In this case, you go down, then up, then down, then up. And so let's see how it looks compared to the periodic table. So if we start over here, we see hydrogen and helium, and that corresponds to the first period. Now we have lithium here, down to neon, and that would be right here. Now we start with sodium, down to argon, that's the third period. And that's so on and so forth. So what you notice, losing this, is that we start up high and then we go down low. Or put another way, as you go across the period, the atomic radius decreases. The question is, why? Well, as you go across a period, the non-valence electrons remain the same, but the protons in the nucleus increase, so the effective nuclear charge increases. If you look at Coulomb's law, where force is related to Q1 times Q2 divided by D, Q1 is increasing. We're increasing the numerator. So, as Q1 increases, the numerator increases. If the numerator goes up, but D remains the same, then the force goes up. The electron is pulled on by a stronger force, so the radius decreases, which actually increases D. So you've got a stronger force, the radius goes down. That is in bullet form. If you want to put it into a statement, I would go with what you see here. Okay, now there's another thing. We talk about groups. Here, if you look carefully, you see that this here is the first group. You start with hydrogen and to francium. If you look here, you got helium, neon, argon, krypton, xenon, radon, and that is group 18. And just for giggles and grins, there is beryllium, magnesium, calcium, strontium, barium, and then radium, and that is the group here, the second group. So you see, you start here, for example. In each of these, you start low and you go higher. So you can say as you drop down a group, the atomic radius increases. And of course, you can be asked why. Well, as you drop down a new group, you add a new energy level. Adding a new energy level will increase the distance between the nucleus and the outermost electrons. Think of it as building a layer cake. The more layers, the taller the cake. The more energy levels, the larger the atom. So atomic radius, as you drop down a group, the atomic radius increases. So here's a pictorial representation of 3 layers versus 4 layers. And in actuality, in discussing the trend in atomic radius as you drop down a group, you don't even need to invoke Coulomb's law. And this is how I would write it out as a simple sentence. So to review, first of all, remember, explanations must include rationale. So going across a period, the atomic radius decreases. So if you're asked, why is the oxygen atom smaller than a lithium atom, you can't say because oxygen is further to the right in the periodic table. That's a description. That's not a reason. The reason would be as you go across the period, effective nuclear charge increases, so Coulombic attraction increases. The electrons are pulled in closer to the nucleus, and therefore the atom gets smaller. As you drop down in a group, the atomic radius increases because adding more energy levels increases the number of levels and thus increases the distance between electron and nucleus. So that's our first atomic trend, atomic radius. We'll move on to ionization energies in the next one, and atomic radius will be used in that a bit. See you for the next lecture.